Okay, so in this video, we're going to be going over the new spark gap design that has been built for the experimental setup. This one is definitely producing the most powerful outputs yet. So we have the new spark gap as well as the new capacitor, and we'll look at what that gives us on the outputs here of the transformer. The new spark gap design. So it looks, it's definitely much bulkier than anything else I've had so far for the spark gap. It's also, the gaps are laid out vertically as opposed to horizontally. That was just for ease of spacing purposes, which we'll kind of go into later. But this is definitely, well, first thing, it has a lot more segments to it. So we have a lot more little air spaces that break when the actual circuit is in operation. But there are a lot of other advantages to this design, which I'm going to go over right now. So this is the spark gap that I have kind of been using for a little bit. It's missing two sections, so normally, we have these extra two little copper tubes in there. But this is kind of what I've been using, and it's been working all right. But there were some issues. One of them is that it gets very tough. Even if you make the distances between these holes exactly alike, it gets pretty hard to get even spacing in between the copper tube sections because of imperfections that may happen when you drill your hole in these tubes. So it's very tough to make them, stand straight up. Even though it seems like it may be easy, it's actually pretty difficult because you don't really have a whole lot of room for air when you're trying to get these, tiny little air spaces, evenly distributed throughout your whole arrangement. So little tiny mistakes can, make something, not work. And then also adjusting it was not a very exact process. So the idea was, if you want to adjust it, so if you want to open it up, you can turn these so they're more perpendicular with the mounting bracket, kind of like that. And then if you want to, decrease the space, you could kind of rotate them like this. So I don't have a whole lot of range of motion here with the amount of space that I separated these, but you kind of see the idea how it's supposed to be adjustable, and it works, but it's just not quite easy getting everything all lined up. So there were some issues that kind of had to be addressed here. And the other thing is, with a design like this where you have these locations kind of drilled out in a mounting plate where you mount these copper tube sections to, as you try to get longer and longer, your problems introduced by imperfections will only increase. So it's kind of a harder design to scale. So that's why I made this design. So what it is it's just wood, like a wood kind of U shape, and inside of that we have all these wooden dowels with copper tubes mounted on them. So these are not actually really mounted, they're just sort of resting in there, and just gravity is kind of holding them in. So we can actually take these sections out and see what it looks like on the inside. Just dump those. This is literally just a wooden dowel, a 1-inch wooden dowel with a 1 1/4 inch copper tube section. So what I did is I put a layer of electrical tape sort of around the middle part of this wooden dowel so that this copper tube fits around it, nice and snug. And it's sort of equidistant from the center line of this dowel. But then I just have a whole bunch of these little sections in here, and I just made these little spacers here. So that's just a little piece of wood. These spacers are just a little piece of wood with 4 layers of electrical tape on either side, just to give it that extra little bit of spacing that's required. And the idea is that it makes it very easy to evenly space everything out, because we just have these little pieces which should be, about the same height for all of our little sections. And then you just take these and add them, and you can, adjust your spark gap very easily. So it's pretty easy to just take sections out or put sections back in, and you can experiment with all sorts of different spark gap configurations. And right now I have it where I pretty much have the maximum amount of sections that I can fit in this thing. So we'll just put that in, and we can just kind of see what it looks like when we're operating. But this is definitely the strongest output that I've ever seen on this machine. Let's just put a little bend there. So yeah, I'll just go turn it on now. Separate this a little bit, get it away from the wood. Okay. I'll go grab my little fluorescent tube. All right, we just flip on the breaker, turn the power on. Get this out of the way. Okay, just gonna start turning it up. And that was, this thing was basically turned up really, really low. So I can tell if I go any higher than this right now, that it's just gonna start to sort of destroy itself. When I turn it on here, I can kind of look inside of these coils, and there's a good bit of electrical activity occurring in between the windings. I think my only real saving grace at this point right now is the fact that the braking is happening so infrequently. But if I were to increase the brake rate and increase the current through those transformer coils, it would certainly destroy itself. So we're kind of right at that point where, we can't really go much further as far as the input into that transformer without that thing just tearing itself apart. But yeah, this is, if you're, building spark gaps for Tesla coils, this is definitely the way to go.